Hello and welcome. This is an intro to the Financial Math TI84 calculator program. And it's basically for you if you're in an intro financial math class, either high school, college, university. And what we'll do is we'll walk through it and see if it's the right program for you. And if it is, you can get it at mcstutoring.com. So good luck with your class, whether you get the program or not, and you'll just see what it can do. Okay, take care. Without further ado, here we go. Here's the main menu: interest, annuities, loans, bonds, depreciation, NPV and IRR, time value, and capital budgeting. Basically, a lot of the topics you'll see in an intro financial math class. So let's go to interest. So we can calculate simple interest, compound interest, and continuously compounding interest. So let's go to the simple interest one. And then here's an example: I equals P times R times T. That's principal times rate times time. With an example, let's say the principal is $1,000, rates 5% times 2 years. So you see here, right, the numbers in action: 1,000 times 0.05 times 2. Just so you know, like, oh, this is how I sort out the variables in my example, or in the one that you're actually doing. But here's the example here. Oh my gosh. Okay, I think you understand what I mean. Okay, and let's do compound interest. So A equals P times 1 plus R over N, all raised to the n times t. Just for the uninitiated, n is the number of times compounded per year. So let's say the principal is 1,000, r is 6%, n is 12, t is 5 years. So we have the 1,000, the principal, times 1 plus the 0.06. Just so you know, the 6% interest rate as a decimal is going to be 0.06. Raised to 12, divided by 12, all raised to the 12 times 5. So there's your answer. So it continues very much the same way. Let's look at continuously compounding. This is a little more interesting. This is a little more real world-ish. A equals P times E, and this is a multiplication symbol. It's also a space invader if you're if you grew up in the 80s. P times E raised to the R times T. And again, example: principal is 1,000, R is 6%, T is 5 years. Some pretty generic numbers here. And then you get what's going on. And the E, just so you know where the E is on this calculator, you're going to press the second key and the division symbol to get the E. I think there's also an E raised to this. So if you press the second and the LN key, it'll give you E, and then you just type in the exponent. So this would be, you run and close in parentheses, by the way, the 0.06 times 5 if you were to do it. Okay, and then that covers interest. Let's go to annuities. So there's different things you can calculate: future value ordinary, present value ordinary, future value due, present value due. So let's go on. So we have future value ordinary. So there we go with some numbers here. Or the actual equations: future value equals P times 1 plus R raised to the n minus 1 divided by R. And then we have some numbers here. The R is 5%, N is 10 years. And lickety split, you got your answer for your future value. So let's go to annuities again, and then present value ordinary. So there's our example there for present value ordinary. Very similar to the future value ordinary. Similar, but not the same. Okay, annuities again. And then future value due. Slightly different equation: P times 1 plus R to the n minus 1 divided by R. All that times 1 plus R. So if we plug it in with the actual numbers here, notice it's times that 1 plus R. That's to the side. It's not part of that denominator right here, dividing by R. And they get future values: $1,320.78. Wow, interesting thing to know about annuities. Okay, and then annuities again, and I think we have the present value due. So there's the example. We have the P is $100, R is 5%, N is 10 years. And then that's 810.78. Okay, great. And then we have loans and amortization payment. So the payment is P times R times 1 plus R raised to the n divided by, 1 plus R raised to the n minus 1. All this is one denominator here, so just be careful when you enter it in your calculator. So there's some numbers there, and it's plugged in, and it looks like that payment would be $954.83 per month. Okay, good. We continue. Again, if this video is helping you, you want to like it. If you want to see more videos coming out. So the next financial math, it might not be out till next semester. That'll be probably early 2025. We'll solve for, actually I want to show solving for any different variable here, And then one, I'll actually, and again, showing it to you. So it's just an equation of forming the program. The next thing would be a solver, and that would be more like spring 2025. Okay, so let's go to bonds. And there we go. This is the value of bonds. This little Greek, this is a sigma. It looks like a Roman E a little bit, but it's a sigma. Usually means sum of C divided by 1 plus R to the T plus F divided by 1 plus R raised to the N. So say the C is $50, R is 5%, the F is $1,000, N is 10. Here's your calculation, and then your answer with $1,000.46. Okay, and depreciation, we've got straight line depreciation, declining balance, and double declining. Let's talk about straight line. So it's C minus S, that quantity divided by L. So let's say it's $10,000 is your C value, your S value is 1,000, and I believe length of it is 5 years. So then it's going to be 10,000 minus 1,000 divided by 5. So it looks like the rate of depreciation is $1,800 per year. So let's continue. And then we've got depreciation again. And then I think that we did straight line. This is declining balance. So C times the quantity D divided by L. There we go. And I think you know how to read numbers, so I just won't continue reading it to you unless it's of pertinent interest here. Again, depreciation, double declining. A little more interested here. It's 2 times C divided by L. So then got your numbers, got your solution. So let's go NPV and IRR. So net present value and internal rate of return. So net present value, we've got the sum of CT divided by 1 plus R raised to the T. That's C times T, by the way, minus C sub O. C sub O is like C at times 0, I believe. So C sub O is negative $1,000. C1 is 500. C2 is 700. R is 10%. So it looks like the net present value is 500 divided by 1.1 plus 700. This C2. So see, this is a sum, or sorry, this is C sub T. Oh my gosh, I misread that. So you have your C values and go on and on and on, minus your C sub O. So yeah, you go C3, C4, etc. So net present value is $42.15. And then we've got internal rate of return there, where NPV is 0. It's solved iteratively. C sub O is negative 1,000. C1 is 500. C2 is 700. So internal rate of return is approximately 15.2%. Next time I'll actually have an equation for you. Sorry, I didn't have one for that. Let's talk about the time value of money, future value versus present value. So future value is present value times 1 plus R. R is probably the percent interest rate, and raised to the end value. So this is pretty cool. As you can see, let's talk about time value again, and then present value, slightly different formula there, and slightly different answer. So let's continue. Capital budgeting. We got a payback period and profitability index. So let's do payback period. And then it's initial investment divided by annual cash flow. So let's say the cost is 1,000, cash flow is 250 a year. So the payback period would be 1,000 divided by 250, which is 4 years. So payback period, 4 years. There we go. And then capital budgeting one last time, profitability index. So it's future cash flows divided by the absolute value of CO. Okay. So the CO is negative 1,000. The PV, the cash flow is 1,200. So it's 1,200 divided by, and again, it's the absolute value of CO. So you take off any sign it has in front, like the negative sign. It's 1.2. If the PI is greater than 1, project is profitable. Okay, great. So this will help you through any basic financial math class, high school, probably university, just total basic class there. Gives you some formulas, gives you some examples, and helps you survive the class. And then probably financial math 2, solving for any missing variable, will come out, like I said, spring 2025. And then a solver, definitely spring 2025 as well. Okay, good luck. Anything in the comments you put, I'll probably adjust this program to suit your needs. Okay, good luck with your financial math class. Check you next time.